This is Mr. Craig, and this video is going to help explain how to determine if something is being oxidized or reduced, and then determining who the oxidizing agent and the reducing agent is. Well, the first thing that we should do is, obviously, if you're given a problem like this, make sure that you first identify what the charges for each of these elements are. So looking at the osmium, and there's one oxygen, so we know that the oxygen's always going to be -2. Therefore, the osmium has to be a +2. Since the bromine is by itself, each one of those is 0. Looking on the product side, we have bromine, that's the only nonmetal, so each of those is going to be a -1 charge, where the osmium is the only metal, so it has to be a +2 charge. Looking at the other osmium, we know that that has to be a +6 charge, because each oxygen still has that -2 charge. So when we look at the overall equation, we notice that some of the osmium actually retains its +2 charge. However, the osmium over here with the +6 is going from a +2 to a +6, which means by that process here that it is losing electrons. Therefore, if something is losing electrons, we say that that's oxidized. So we can go ahead and say that osmium +2 is being oxidized. One thing to remember is that when determining who's oxidized or who's reduced, that it has to be on the reactant side. And also remember that when we're determining who's oxidized or who's reduced, that it has to be a single type of element. Well, when we look at the equation, we notice that the oxygen keeps that -2 charge from the reactant side to the product side. So we go to the bromine, and we notice that the bromine has no charge, where it goes to a -1. So if we write out the equation, just a simple half reaction, we're not writing out a redox half reaction here, but we're just wanting to show how these charges change. So bromine that has no charge on the left side and then gets a -1 means that it gained an electron. So if it gains an electron, we say that that is reduced. Now be sure that you include the charges when you determine who's oxidized and who's reduced. Alright, for determining who the agent is, do recall that the agent allows for the other thing to be oxidized, or if we're looking at the reducing agent, it allows for the other thing to be reduced. So since we know that the bromine is actually being reduced, it allows for the osmium to give away its electrons and be oxidized. So the oxidizing agent in this case is the whole package, so that means that we're looking at the bromine molecule. Now that means that there's 2 bromines there, so we have to include everything that's included that the bromine came packaged in. Looking at the reducing agent, we know that the osmium +2, again, has to be on the reactant side, contains the oxygen. So the reducing agent is the osmium oxide, or more specifically, the osmium Roman numeral II oxide. Okay, let's look at the second example here. Again, do the same thing. Determine what the charges on each of these things are. So we have the oxygen that is -2, and therefore each chromium has to be a +3 charge, since we only have 2 of those. The hydrogen and the nitric acid's +1, each oxygen's -2, and do recall that all the charges have to equal 0, therefore the nitrogen must be a +5. On the product side, again, the oxygen's -2, we have 2 of those, so the nitrogen is a +4. And then on the last molecule, we have the -2 for the oxygen. We have 3 of those, therefore the chromium has to be a +6. Alright, so again, take a look at the before and after situation, and it looks like we have chromium with a +3 charge going to a +6 charge, which means that in the process it's losing electrons. So we can automatically say that the chromium +3 is oxidized. Okay, now again, I'm just looking for really rough half reactions. You don't have to write the whole half reaction out. Actually, if you get good enough at this, you'll be able to recognize just by looking at the charges and be able to recognize, oh, okay, that's becoming more positive, therefore it's losing electrons. Again, the oxygens remain the same charge on both sides, so we don't have to worry about that. The hydrogen only appears one time on the left, so we're assuming that when we see it in a water molecule, if this were a redox equation, it would still retain that +1 charge. So the only other thing left is the nitrogen that has a +5 going to a +4. And yes, it is being reduced because it is becoming more negative, even though it still has a positive value. So that means that it's gaining an electron. Therefore, the nitrogen +5 is being reduced. Alright, so again, determining who the agents are, look at who is allowing the other thing to be oxidized if we're looking for the oxidizing agent. Therefore, since the nitrogen is reduced, it's allowing the chromium to be oxidized. Therefore, the agent for the oxidizing agent is the nitric acid. And you'll find out that actually nitric acid is a very nice oxidizing agent as we talk more and more about these throughout the year. Then the other thing must be the reducing agent, the other reactant, and in this case here it looks like the chromium 3 oxide. And again, include the whole compound. Alright, I hope this has helped explain oxidation reduction and the agents. If you have any more questions, by all means, let me know.